Assalamualaikum and good morning to madam and friends. Today we would like to discuss about topic 5 timber. First is plywood. What is plywood? Plywood as a building material is very widely used due to its many useful properties. It is an economical factory-produced sheet of wood with precise dimensions that does not warp or crack with change in atmospheric moisture. Ply is an engineered wood product made from 3 or more plies or thin sheets of wood. These are glued together to form a thicker, flat sheet. The logs used to make plywood as a building material are prepared by steaming or dipping in hot water. They are then fed into a lathe machine, which peels the log into thin plies of wood. Each ply is usually between 1 and 4 mm thick. Uses of plywood as a building material. Plywood has a huge range of use within the construction industry. Some of its most common uses are to make light partition or external walls, to make formwork or a mold for wet concrete, to make furniture, especially cupboards, kitchen cabinets, and office tables, as part of flooring systems, for packaging, and to make light doors and shutters. How ply is made. Plywood consists of the face, core, and back. The face is the surface that is visible after installation, while the core lies between the face and back. Thin layers of wood veneer are glued together with a strong adhesive. This is mainly a phenol or urea formaldehyde resin. Each layer is oriented with its grain perpendicular to the adjacent layer. Plywood as a building material is generally formed into large sheets. It may also be curved for use in sealing aircraft or shipbuilding. Which wood is ply made of? Plywood is manufactured from softwood, hardwood, or both. The hardwoods used are ash, maple, oak, and mahogany. Douglas fir is the most popular softwood for making plywood, although pine, redwood, and cedar are common. Composite plywood can also be engineered with a core of solid timber pieces or particle board, with a wood veneer for the face and back. Composite plywood is preferable when thick sheets are required. Additional materials can be added to the face and back veneers to improve durability. These include plastic, resin impregnated paper, fabric, formica, or even metal. These are added as a thin outer layer to resist moisture, abrasion, and corrosion. They also facilitate better binding of paint and dyes. Properties. First, high strength. Plywood has the structural strength of the wood it is made from. This is in addition to the properties obtained from its laminated design. The grains of each veneer are laid at 90 degrees angles to each other. This makes the whole sheet resistant to splitting, especially when nailed at the edges. It also gives the whole sheets uniform strength for increased stability. Furthermore, plywood has a higher strength to weight ratio as compared to cut lumber. This makes it ideal for flooring, webbed beams, and shear walls. High panel shear. Plywood is made with an odd number of layers, making it tough to bend. The angle at which the veneer grains are laid against each other may be varied from 90 degrees. Each veneer can be laid at a 45-degree or 30-degree angle to the next one, increasing the plywood strength in every direction. This cross-lamination increases the panel shear of plywood, important in bracing panel and fabricated. Third is flexibility. Unlike cut timber, plywood can be manufactured to fit every requirement. The thickness of each veneer can vary from a few millimeters to several inches. The number of veneers used also range from 3 to several, increasing the thickness of the sheet. The extra layers add more strength to the plywood. Thinner veneer are used to increase flexibility for use in ceilings and paneling. Next is moisture resistant. The type of adhesive used to bind the veneers make the plywood resistant to moisture and humidity. A layer of paint or varnish can also increase resistance to water damage. This type of veneers are suitable for exterior use such as cladding, sheds, and in marine construction. They are also suited for holding concrete while it sets. Moisture resistance is important in interior application as well, including on floors. The cross-lamination ensures the veneers do not warp, shrink, or expand when exposed to water and extreme temperature. Other than that, chemical resistant. Plywood treated with preservative does not corrode when exposed to chemical. This makes it suitable for chemical wards and cooling towers. Next is impact resistant. Plywood has high tensile strength derived from the cross-lamination of panels. This distributes force over a larger area, reducing tensile stress. Plywood is therefore able to withstand overloading by up to twice its designated load. This is critical during short-term seismic activities or high winds. It is also useful in flooring and concrete formwork. Fire resistant. Plywood can be treated with a fire-resistant chemical coating. More commonly, it is combined with non-combustible materials such as plasterboard or fibrous cement. This makes it ideal for use in fire-resistant structures. Insulation. Plywood has high thermal and sound insulation. This makes it a useful insulating material for flooring, ceiling, roofing, and wall cladding. Insulation offered by plywood can greatly reduce heating and cooling costs. Now I'm going to talk about types of plywood. First is structural plywood, used in permanent structures where high strength is needed. This includes flooring, beams, formwork, and bracing panels. It can be made from softwood or hardwood. Then, external plywood, used on exterior surface where a decorative or aesthetic finish is important. It is not used to bear loads or stress, such as on exterior door surface and wall cladding. Other than that, internal plywood, this has a beautiful finish for non-structural application like wall paneling, ceilings, and furniture. Last is grades of plywood. Plywood grades are determined by strength, discoloration, surface defects, and resistance to moisture among other properties. The quality of surface veneer, type of wood, and strength of adhesive will then be allocated a particular rating. Each rating will determine the type of application the plywood is suited for. Plywood grades are N, A, B, C, and also D. The D grade has several surface defects such as graining and knotting, while the N grade has few of these. An interior CD rating, for example, indicates the plywood has a grade C faces and a grade D back. It also means the adhesive is suited for interior applications. The unique characteristic of plywood is cost effectiveness and ease of use. We've continued to popularize plywood as a building material.
Assalamualaikum. So the next part is glue laminated timber by me, Nur Nilamsari binti Muhammad Razali. What is glue laminated timber? Glue laminated timber is a structural material manufactured through the union of individual wood segments. When glued with industrial adhesive, usually melamine or polyurethane resin adhesive, this type of wood is highly durable and moisture resistant, capable of generating large pieces and unique shapes. Suitable for use on beams, pillars, ceilings, stairs, panels, and cladding. One of the great advantages of these types of structural wood is the ease with which it can produce shapes or curves in beams or pillars. Another interesting feature is its diversity of tones, since there are a multitude of wood species available. The most used species include eucalyptus in brown pink or beige pink, versions and pin. The connection between different elements can be made with steel connectors. Advantage: unique dimensions, high load capacity and low weight. Glulam allows you to cover large areas with small components. It can cover sections of up to 100 meters without intermediate support. Resistance: successfully resists various chemicals. It also resists transformation caused by moisures such as deformations and or tensions. Flexibility: curved edges and folded shapes are reproduced quite easily. Pieces also don't necessarily need to follow the geometry of the tree trunk. High fire resistance: structures made of good laminated timber are safer than unprotected steel in fire. This is because a carbonized layer forms around the glulam's core, decreasing oxygen conceptions and retarding combustions. Dimensional stability: Glulam has a humidity of 12%, which corresponds to an equilibrium humidity of 20%, which corresponds to an equilibrium humidity of 20 Celsius and 65% relative humidity. Contractions and swelling behavior is therefore minimized. Less needs for connections: these structures may require a smaller number of joints when covering large openings without intermediate supports. Lightness: this feature is maintenance and assembly or disassembly. Studies show that a glulam beam has the same strength as a concrete beam of the same volume. Yet the weight of the piece of wood is approximately 5 times less. Sustainability: serious suppliers operate primarily with reforestation wood. We recommend reviewing this information by looking into the specific type of wood in your projects. A useful tip is look for the Forest Stewardship Council's FSC certification seal. So, about the manufacturing process, the manufacturers of glulam brings together two very old techniques, the gluing techniques and the lamination technique. Therefore, when talking about glue laminated wood, we talk about a wood composed of pieces glued and bound together with parallel fibers. To generate efficient structural elements, the pieces must be joined with adhesive of such high resistance that they can replace the joints usually made by steel elements and screws. Glue laminated timber is manufactured with an optimum degree of humidity, minimizing contractions and swelling behavior and guaranteeing the dimensional stability of the material. So what kind of projects can be used? Glulam timber is recommended for any type of construction from residential projects to industrial buildings. It can even be applied to buildings located in areas with specific climatic demands, provided that a moisture protection treatment is applied.
Hello, I'm Vijayavishnu and I will continue talk about fiberboard. Okay, what is fiberboard? Fiberboard is a type of engineered wood product that is made out of wood fibers. Types of fiberboard include particle board or low density fiberboard (LDF), medium density fiberboard (MDF), and hardboard high density fiberboard (HDF). It is sometimes used as a synonym for particle board, but particle board usually refers to low density fiberboard. Plywood is not a type of fiberboard. as it is made of thin sheets of wood, not wood fibers or particles. Fiberboard, particularly medium density fiberboard, is heavily used in the furniture industry. For pieces that will be visible, a veneer of wood is often glued onto fiberboard to give it the appearance of conventional wood. In the packaging industry, the term fiberboard is often used to describe a tough kraft-based paperboard or corrugated fiberboard for boxes. Fiberboard is also an intermediate product and output of a pulp mill used as input for a paper mill. Okay. Fiberboard have three types, and the first one is low density fiberboard (LDF), and the second one is medium density fiberboard (MDF), and the last one is hard density fiberboard (HDF). Okay, first, low density fiberboard. Low density fiberboard (LDF) is often used when there is a need to reduce weight without sacrificing its versatility. Due to its low density, it is light and made handling much easier. It has excellent machinability and consistent core which make it suitable for architectural moldings, trade and show exhibits ready to assemble furniture and many more applications. LDF are normally in demand when manual handling, tooling or freight costs are a major consideration. In addition, our LDF has a general-purpose board, bright color board, and latex-free board, pending the application of the boards. Next, medium density fiberboard, an engineered composite wood product made from residues of hardwood and softwood, gluing together with wax and resin under extreme pressure, and pressure is called medium density fiberboard or MDF wood. And the last one is hard density fiberboard. Hard density fiberboard is like MDF in that it is a man-made composite panel product that is manufactured from compressed wood fibers. It is a stronger, harder product than MDF with a typical density up to 900 kg meter cube. HDF is predominantly used in laminate flooring products where its density is required, though other uses include door skins and underlayment. HDF is a very thin board, which is typical thickness of 3 mm to 8 mm, and is also often supplied perforated, meaning it is completely inappropriate as substrate for creating interior moldings. You may have seen HDF in a home, as it is also commonly used as backing panels for furniture. If so, you will understand how unsuited this material is for creating skirting boards and architrave. Okay, the next one is uses of fiberboard. Fiberboard has many benefits and is used in residential and commercial construction. Applications include soundproofing or deadening, construction sheeting, low slope roofing, and sound deadening flooring underlayment. Fiberboard is also used in the automotive industry to create free-form shapes such as dashboards, rear parcel shelves, and inner door shells. These pieces are usually covered with a skin, foil, or fabric such as cloth, suede, leather, and polyvinyl chloride. RSI Direct, a bi-weekly e-newsletter covering the roofing, siding, and insulation industries, promotes the use of fiberboard as a coverboard in roof systems. High-density coated wood fiber is an ideal coverboard, and the industry apparently agrees. More than 2 billion square feet of this product have already been installed in the US roofing market. In terms of cost and availability, wood fiber is hard to beat. Next, about the manufacturing process. Fiberboard manufacture begin with wood chipping. Fresh or recycled wood material is cut and sorted to small pieces of similar size. Chips are washed to remove things such as dirt and sand. Metal scraps such as nails can be removed with a magnet placed over a conveyor belt which the chips move forward. In the case of, for example, MDF is not particle board, chips are then steamed to soften them. Defibration. Small amount of paraffin wax is added to the steam chips and they are transformed into fluffy fibers and the defibrated and soon afterwards sprayed with adhesives such as urea formaldehyde (UF) or phenol formaldehyde resin. Wax prevents fibers from clumping together during storage. Chips in the case of particle board are also sprayed with a suitable adhesive before the next steps. Fiber or chips are arranged into a uniform mat on a conveyor belt. This mat is pre-compressed and then hard pressed. Hard pressing activates the adhesive and glues the fibers or chips together. Board is then cooled, trimmed, sanded, maybe vinyled or laminated. UF resins are dominantly used in the MDF industry because of their low cost and fast curing characteristic. However, pressures on the use of UF resins are mounting steadily due to potential problems associated with formaldehyde emission. On the other hand, PF resins are more durable and do not emit formaldehyde after cure. The industry has traditionally shied away from using PF resins due primarily to their higher cost and much slower curing rate than UF resins. However, the press time of PF bonded fiberboard can be substantially reduced by manipulating the fiber mat temperatures, molecular weight distribution of PF resins, and pressing parameters. As a result, the press times of PF bonded fiberboard can be can be made comparable to those for UF bonded fiberboard. Also, the resin content required for PF bonded fiberboard is less than 5% to achieve a good board quickly. This is considerably lower than that required for UF bonded fiberboard. Certain type of fiberboard can be considered green building products, consisting of bio-based secondary raw material, wood chip or sugarcane fibers, recovered from within 100 miles (160 km) of manufacturing facilities. The binding agent used in this type of fiberboard is an all-natural product consisting of vegetable starch containing no added formaldehyde. Okay, uh, they got advantages of using fiberboard and also disadvantages of using fiberboard. And the first one is advantages of using fiberboard. Uh, First, impact and thermal insulation in one product, and then excellent thermal and acoustic improvement. Reduces ridges and uneven surfaces in subfloor, and then robust and stable support for final floor finish. Helps increase serviceable life of final floor, high load bearing and weight resistance, high lightweight and easy to handle, quick and simple to install, environmentally friendly composition, and the last one is inexpensive product. And the disadvantages of using fiberboard is weak compared to the wood and not as durable as real wood, requires more nails when installing it, might take more time to install compared to real wood.
Bismillahirrahmanirrahim. Assalamualaikum and salam sejahtera to my medium and my friends. Sebelum tu, my name is Muhammad A'la Naufal bin Saiful. My matric nombor 15 DKA 21F1034. Okay. Today, I going to talk about the particle board. Okay. What is a particle board? Also known as a chipboard, is an engineered wood product manufactured from wood chip or just chip and synthetic resin or other suitable binder, which is preserved and extruded. And second, a particle board. Board is often a composed with a orient, oriented strength board, also known as a flatboard, paperboard, or chipboard. A different type of fiber board that use machine wood, flat and offer. Next, can I going to talk about the manufacturing process. The first, particle board or chipboard is manufactured by machine particles or flats or wood or just stick together with a and resin and forming the mix into a sheet. The raw material is fit into this chipper with between 4 and 16 radially wrangle blanks. The chip from these chippers are more uniform in shape and size than from other types of wood chipper. The particles are then dry, 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 and any oversized or undersized particles screen out. Resin is then spray as a fine mist although the particles. Various types of resin are used in the process. Amino formaldehyde-based resin are the best performing based on the cost and ease of use. Melamine resin offer water resistant with more melamine offering high resistance. It is typically used in internal application with the colored resin adapting the panel to feature enhance the panel properties. Resinol resin can be mixed with a phenolic resin, but that is more often used with very natural wood application. Next, panel production involves other chemical in the final product resistant to water, fire, or insect. After the particles pass through a mist of resin sufficient to coat a surface, they are layer into a continuous carpet. The carpet is then separated into discrete rectangular blank layers which will be compact in a cool place. A scale with the flats, and they are distributed by rotating rakes. In grade, this particle board, the flats split by an a that through finer particles feature that then cause one to suggest receive allow the particles to build up from fine to coarse and and back to fine. The format sheets are called a compressor to reduce thickness and make things easier to transport. Later they are compressed again under pressure between 2 and 3 megapascal 209 and 404 psi, and temperature between 140 and 220 Celsius to set and harden the glue. The entire process is controlled to ensure the correct size, consistency and consistency of the board. The boards are then cooled, trimmed and sand. They can then be sold as raw boards of improved through the addition of wood veneer or limited surface loading waste dies, reaching again and release again to aid processing or matte. Okay, next advantage of using a particle board. Cross section of a particle board is cheaper, denser and more uniform than a conventional wood and plywood, and is a substitute from then when cost is more important than strength and appearance. And number two, particle board can be made more appealing by painting or the use of wood veneers of visible surface. Next, so two top is top two two is it is denser than a conventional wood. It is the lightest and weakest type of a fiber board. Aspect for insulation board. Medium density fiberboard and hardboard, also called high density fiberboard, are stronger and denser than a particle board. Different grades particle board have a different density, with high density connoting greater strength and greater resistance to failure of a screw fastening. And next, disadvantage of using particle board. Susceptibility, extension and discoloration from moisture absorption, particularly when it is not covered with a pen or other shader. It is rarely used outdoor or in place where there are high level of moisture, especially in bedrooms, kitchens, and laundries, where it is commonly used as an underlayment shielder beneath moisture resistant continuous sheet of fine flooring. In dry environments, veneered particle board is cheaper over veneered plywood because of its stability, lower cost, and Okay, the last one is safety. Safety constant assist for both manufacturing and use. Find dust and chemical release when a critical board is machined. And number two, occupational exposure limits exist in many countries, recognizing the hazard of wood dust. Cutting a particle board can release formaldehyde, carbon monoxide, hydrogen cyanide in the case of amino leucine, and phenol in the case of phenylformaldehyde resin. And that's all for me. Thank you very much.